Good afternoon. This afternoon, we are going to be talking about our senior project. My name is Samuel, and I'm the team lead. And next is going to be uh, my team, who are going to who are also going to do a brief introduction.
Hello, I'm Benjamin Gress. I was in charge of developing parts of the backend and also hardware procurement and deployment.
My name is Aslam Boanika. I'm the UI UX designer and front end developer as well.
My name is Jackson Philbrook, and I'm a full stack developer. So currently, organizations rely on data more than they ever have in the past. Both employee feedback and user feedback is used to drive every business decision. Multiple choice questions are easy to analyze because there's only so many options with traditional data analysis tools. But text data gives users a lot more options on what they can say, but is really hard for computers to understand it. Current AI tools are great at generating text, but they have their own issues at the moment as well. So they can't be used purely on their own. The solution to this problem is the Streamliner application. We combine traditional data analysis tools and AI. It's a full survey application where users can create their own surveys, publish their surveys, and then after they receive feedback from them, we can analyze them using both traditional data analysis and AI analysis. We use natural language processing to analyze the text data, prioritize responses, and generate insights for the user. And then we use traditional data analysis to create visualizations for the trends and to highlight trends between multiple questions. The AI tool can do sentiment analysis as well, tracking user ideas and emotions towards what they're talking about, and also create summarizations of large amounts of data.
The budget. So Ovation Technology Group project. Items is AWS usage, which is $50. Chat GTP API usage is $50, so total is 100. Budget overview. Estimated cost is AWS services, ChatGPT API usage, tooling platforms. Actual costs covered under educational credits and Ovation support. No additional expenses from team members or School of Engineering. No major budget changes or occurred. Costs stayed within expected bounds. Financial efficiency due to using pre-existing models and free tier services. Use cases. Customer feedback problem. Companies collect lots of feedback but can't easily prioritize actionable items. Streamliner analyzes feedback to find key themes and rank them by importance. Businesses address top issues and boost customer satisfaction. Employee feedback analysis. Organizers struggle to process and act on employee feedback. Solution. Streamliner highlights key themes like culture or efficiency issues. Outcome. Improved employee satisfaction and retention by tackling critical concerns. Use cases continued. Extracting important information. A company serves users about an app. Most users say typical things, but one single user points out a new security flaw. Solution. Streamliner analyzes feedback and informs the organization about the pressing matter. The outcome is the company gets all the important information and can address the vulnerability. Employee sentiment analysis. Organization surveys employee on their new outreach program. Users write free response, all saying positive things, but the organization can't read every response. Solution. Streamliner highlights key themes and users' sentiment, summarizing the user's responses. Outcome. Organization understands the feedback and can act on it.
So here we have the block diagrams for the application. On the left, we have the network and application structure. You can see the user accesses the front end of the website, which communicates with our API entry point. That connects to the SQL server to get the surveys and the responses. And then the backend API endpoint we use to get so that can display to the feedback portal. And then the AI API we use to analyze the responses using the AI analysis. The traditional data analysis happens in the backend API backend, the Streamliner backend. And then on the right, we have the functionality block diagram. You can see the developer portal connects the users to view responses and analytics. They can create and manage their forms, and they can go directly to the backend, communicate with, so that the end user, the person taking the form, can take that, and then when they submit their answers, it'll be stored on the SQL server, and the backend communicates with the OpenAI API for the data analysis. So the first challenge we had to decide was whether or not we were going to create our own model or use an existing model. Using our own model would give us more flexibility over everything that it does, but it's a lot harder to do that, and it uses a lot of hardware power that we don't have. So we decided to use the OpenAI model instead. Then we had to decide what tools we're going to use to host it. So we decided with AWS after we looked into lots of tools and what we needed, and then considered cost as well. Then we faced challenges because we had to learn a lot of industry standard tools that we haven't used yet to design it. So we used Figma for UI design, and then Postman and the RESTful API design to design those APIs and test them, and then Spring Boot as well for that. And then after we learned those technologies, we had to integrate them with everything we already know. So we mapped out the system architecture and then identified every dependency we were using. And then to make sure that all that works, we continue to test and troubleshoot and refine the connections between the components. So as far as risks go, the risk of a data breach would be where hackers got into the system and retrieved both the surveys and the results from the SQL server. That would lead to them getting access to everything that we have. There's not a whole lot on there, but for state agencies, they could have confidential information. So we do have to be mindful that we have up to date with our confidentiality, and then authorization and authentication for users has to be really well. We do that with JSON Web Tokens to ensure that the user logged in only has access to what they have. Similarly, if the website was hacked and defaced, that could be bad for the organization. So we had to ensure the data integrity to make sure that for both the surveys and our systems, our documents. And then project implosion, issues communicating, and then the business not following through either. If the AI API goes down, we can no longer analyze that because that's happening on their servers, not ours. So we need to have alternatives to other AI analysis tools if that happens. And if the AI bubble pops and there's no AI available, then we could lose our ability to do all of that analysis, and we would lose. So we'd just purely beat the traditional data analysis.
Alrighty, so as for our external interface requirements, we have a feedback portal, which is very important. Of course, you need somewhere where you can actually go to create a survey, customize it, put down the questions you want, put in the types of questions you want, all that fun stuff. We need dashboards so that you can view the actual information and kind of just like what you're getting from your end users, the people who are filling out the surveys. You want to have a nice place where you can just go and see all the information laid out perfectly in front of you so that you know what you're looking at and you know what those insights are, which is the intention of this project. We also want to make sure that there are customization tools in order to actually build and implement surveys, like some kind of survey builder where we can actually like go forward and say, here's this the question, it goes here, and there's this next question that goes there, that kind of thing. We also need to have API integration. We need to connect with our survey tools, our CRMs, and our communication apps. As I understand, our survey is an external provider, the thing that actually generates the JSON files that we convert back into surveys. And our communication apps is probably like AEI stuff and all that kind of fun information where we actually do processing to parse through all that. We're also going to need, for our data management, secure storage and export capabilities. Export capabilities is provided by our Python code. It will automatically convert the queries it receives from the systems into like CSVs, Excels, all that fun stuff, whatever the user wants it as. And for secure storage, that's on our end. We need to make sure that we are storing the data securely, that our best security practices are in place. We have firewalls, we have vulnerability scanners, we have other stuff on the network that's making sure that we're able to show that like there's a security to it. The point is, there are things in place so that if something does happen, we have mitigating strategies and we can prevent those things from happening in the first place. And we also want notifications, reports, regular alerts, and updates so that you know what is going on with your survey. For our non-functional requirements, for everyone always, we need ease of use. We need users to be able, and from the public and from within our organization, to be able to just go and do things. If they don't have ease of use, they won't be able to do their stuff quickly and finish it up or even understand what they're doing. We need maintainability. We need that code base to be nice and portable. We need to be able to be easily replicable. We need to be able people to be able to just work on it and make modifications as they need. For security, we want to do the aforementioned things. We want to implement like systems and mitigation strategies and all that fun stuff so that you're able to keep your data safe and you're able to ensure that everything will be all right and that there's no ever an event where you have to worry about the data being breached. For scalability, we also need to make sure that it is ready to be like stateless computed so that you can have multiple hosts running the same Python application where you can be able to distribute the network traffic and all these different requests and all these different surveys coming in so that people don't experience weird lag times, they don't experience their survey getting deleted in transit, all that fun stuff where it's able to basically adapt to anybody's computational needs, especially given how much hardware they have. And then speed, this stuff is time sensitive. You want that information that you're getting from your end users as fast as you possibly can. That is our number one priority. We want to make sure that you get the insights that you need to make your business run better as fast as you want them. And that our system is hopefully designed for that. So how we did this, we followed an agile sprint structure where we were able to quickly adapt on the fly and ensure that we are following changing user requirements, ensuring that our user knows that we're doing things for them that they need within quick times and that we have a good turnaround time on adapting to everything they might throw at us or anything that just doesn't work in a prototype. We also broke down our large tasks into 2-week sprints. So large tasks like the actual total implement this web system was split into different components, the AI, the CRUD operations, so that we can, read, write, and understand data from the database, basically. And the actual survey implementation of like including our survey generator, survey displayer, survey editor, all that was each one of those was a sprint. We also had internal bi-weekly stand-ups to discuss work led by either me for the first semester or Samuel for the second semester. We also had weekly meetings with our client where we would go over all the stuff we needed to go over and ensure that we were staying up on a project schedule ensure that we were getting the requirements right, and ensure that everything that they needed us to do was getting done right. And then after sprints, we would adjust and modify the backlog as always in order to make sure that we had knowing what we needed to do next.
And I will be talking about the technical constraints and ChatGPT API integration. We are currently ongoing integration of ChatGPT API for processing feedback. Another constraint is the cost and limits. We need to manage the token base and rate limits, and there's also external dependency. We are relying heavily on OpenAI uptime and reliability, privacy concerns, compliance with data protection regulations. Example GDPR, and our workarounds are we are optimizing our prompt, implementing response caching and basic NLP fallback logic. And this slide is what we are currently doing and what our schedule looks like. So this project was split into 4 key sprints over the course of the entire semester. Sprint 1 was the backend infrastructure, which is done. Sprint 2 was the SQL database, which is also complete. And the next one is the AI interface, which we are working on as of now. And we've had regular meetings with our clients to share milestones and to make sure everything is on track. So we've been constantly in contact with our team at Ovation to make sure that everything is nicely done. And design, decisions, learning, and the principles applied in this project. We used an agile sprint type of so we use an agile sprint, and the tools that we researched was Monkey-Learn, Google NLP, and AWS Comprehend. We did this research before we actually chose what we were going to use. So we decided to use ChatGPT, which is very popular as of late. And our third design principle is the prompt engineering. We have to make sure that our prompts design are effective and consistent with the AI responses. The fourth is the compliance and security. And we did our best to align with the privacy laws and the best practices available as of late. And and the next slide is about the identified risks and how we are going to respond to these risks. There's a very high chance of API downtime, which could disrupt with the analysis and fallback with analysis. And our response is that we are in the process of developing an NLP logic in the development. The second risk is website hacking or the breach of data, which could compromise user input. And how we are responding to this is encryption and making sure that our authentication is nice and secured. The other risk of this project is OpenAI's policies, and OpenAI policies. And with that, we have a modular design that enables API. Basically, we are able to switch our API to a different system if need be. The other risk is AI hallucinations, which can cause a risk of inaccurate responses. And we've included a post processing and admin review. There's also a risk of an AI bubble, and that there could be a potential decline in AI trust. And our response is that we have traditional data analysis, which we could use if that may happen. So we are not heavily reliant on ChatGPT or anything like that, but it's just another step to make sure that our software is it, yeah, functions. And this next step, I'm gonna let Aslam let you guys know about what we have to do in the future. Thank you.
Next steps and future plans, finalize AI integration and conduct comprehensive testing, complete user interface design and deploy a full prototype. Ovation has shown interest in using the system post demo. Potential future users include internal HR feedback tools and product feedback platforms. Team is exploring long-term commercial possibilities such as SaaS offering.
And this concludes the end of our presentation. I hope to see you guys in person so we can show you guys what we have, and have a wonderful day. Bye.